Hello, everyone. Welcome to chemistry. Today we're going to look at electronic configuration of noble gases. And last time in another lesson where we're looking at how to arrange electrons in an atom, we also looked at there are certain atoms that have got 8 electrons in their outermost shell. So those atoms, they are found in group 8 and we call them noble gases. So they are going to look at the noble gas electronic configuration. Okay. So the noble gases, they are found in group 8. So in group 8 or group 0 of the periodic table. So these gases, they are found in this group because they've got either 2 electrons or 8 electrons in their outermost shell. And they are called noble gases because they are stable, meaning that they are reactive. They do not combine with any other atom to form compounds. So these are stable. Why are they called stable? Because they've got 8 or 2 electrons in their outermost shell. So let's look at the example of this. The first one we're going to look at is helium. So helium has got only 2 electrons. The next one is neon, which has got 8 electrons in the outermost shell. Then I've got argon, which has got 18 electrons. So I've got 8 electrons in the last shell. So in the previous lesson, we said the electrons that are found in the last shell, they are called the valence electrons. As we can see, helium has got only one shell and there are 2 electrons. So it has got the maximum number of electrons. So we say helium has got a duplet configuration. Then these ones, they have got 8 electrons. So we say they've got an octet configuration. So these elements have got 2 electrons, and these 2 electrons is found in the first shell, and that's the only shell. It means that helium, it is stable. It cannot give or lose any electron. Neon and argon, because they've got more than one shell, it means that they need to have an octet configuration in which they must have 8 electrons in the outermost shell, meaning that when they've got these 8 electrons, they are stable. Stable and reactive. They cannot react. So the noble gases, they are found in group 8 because they have got 8 electrons in the last shell except for helium. Or we can say they are found in group 0 because they are stable. They don't react by either losing or gaining electrons. So from this configuration, we can see that for an atom to be considered to be stable or unreactive, it must have 2 electrons if it has got only one shell. Or it must have 8 electrons in the last shell, it has got more than one shell. So if you say hydrogen, for hydrogen to be stable, because it only has one shell, it means that for it to be stable, it must have 2 electrons. But for any other element that has got more than one shell, for them to be stable, they must have 8 electrons in their outermost shell. So the periodic table, we said it is a list of elements that were arranged according to the atomic numbers. So most of them, they are not stable. It means that they don't have 2 electrons, those that have got only one shell, or they don't have 8 electrons for those that have got more than one shell. Now, for them to be stable, like the way the noble gases are, they have to undergo either losing electrons, gaining electrons, or sharing of electrons. So the noble gases, they are special elements on the periodic table. These other elements or these other atoms, they want to become like noble gases. So for them to become like noble gases, they must lose electrons, they must gain electrons, or they must share electrons, so that they've got either 2 electrons or 8 electrons in the outermost shell. So we have said that for an atom to become like a noble gas, to become stable, to become unreactive, it must either lose electrons or gain electrons, or by sharing of electrons. So if an atom loses electrons or gain electrons, or they do share electrons, it means that their aim is to become like noble gases, or to have a configuration which has 8 valence electrons or 2 electrons in the outermost shell. So I've got elements like lithium. For it to be stable, it must have 2 electrons. Then I've got elements like sodium. So sodium is like this. For it to be stable, it must have 8 electrons in the outermost shell. So The atoms that lose electrons, these are atoms for metals. Then the atoms that gain electrons, these are atoms for non-metals. And the ones that do share electrons, these are atoms only for non-metals. So the periodic table has got different atoms, and these atoms, they are for either non-metals or for metals. So the atoms are found in the elements. We have said for atoms to become stable, they either lose electrons, gain electrons, or share electrons. So I've said that there are certain atoms for metals and some for non-metals. So those atoms are for elements. So an element is a pure substance. So it's a pure substance that cannot be broken down to two or more simpler other substances by a physical means. So now, if an element cannot be broken down to other simpler substances, then it means that that element must be made up of the same type of an atom. Okay. So these elements, they can either be metals or non-metals. So the element is a pure substance, and you cannot break it down to other simpler substances. And we have said we have got metals and non-metals. So the atoms that you're looking at can be atoms of metals and atoms for non-metals. Now we want to know, how do these atoms become stable like the noble gases? So we're going to have another lesson which will involve elements, which are going to know more about the metals and also the non-metals. But for today, we want to know how the atoms for non-metals and atoms for metals become stable like the noble gases. So we said they become stable by losing of electrons. Then you have said gaining of electrons, and you have said by sharing electrons. Losing of electrons is only for atoms for metals. Then gaining and sharing is only for atoms or for non-metals. So atoms of non-metals, they will either gain electrons or they will do share electrons. Then for atoms for metals, then they will lose electrons. So we'll start with the losing of electrons. So we already know that the ones that are going to lose electrons, they are atoms for metals. A good example now is, we'll start with sodium. Sodium has got the atomic configuration of 2,8,1. So the losing of electrons, these electrons that are being lost are valence electrons, electrons that are found in the last shell. So in this case, sodium has got only one electron in the last shell. So the sodium will lose this electron in the last shell, so it will become 2,8. Now, because it has lost an electron, it's going to become positive. And in this case, it has lost only one, so it will be positive 1. So metals, atoms of metals, they lose electrons, and when they lose electrons, they are going to acquire a positive charge. So the size of the charge depends on the number of electrons they are going to lose. So in this case, sodium has lost only one electron and is going to form a positive 1 charge. We can look at another one. Let's say magnesium, 2,8,2. So magnesium is found in group 2 because it has got 2 valence electrons, and in this case, it's going to lose the 2 electrons. So it's going to lose these electrons. So magnesium is going to be 2,8. It has lost 2. So because it has lost 2, because of losing, it become positive. How many electrons? 2 electrons. So it becomes positive 2. So magnesium has lost 2 electrons. This sign, the positive sign, it is showing that magnesium has lost electrons. Then the 2, it shows that it has lost 2 electrons. So during the losing of electrons, they become positive. And when they lose electrons, the atoms become ions. So an ion is a charged particle that is formed when an atom loses or gains electrons. So an ion can only be formed if an atom, it loses or it has gained electrons. So in this case, sodium has lost this is an atom, it has lost electrons, it has become sodium plus. Magnesium atom, after losing 2 electrons, it has become an ion. So even lithium, it is 2,1. So it's going to lose the 1 electron that it has. So after losing 1 electron, it become lithium. So it has become lost one electron. So this is an atom, this is an ion of lithium. Now, remember we said the number of protons, electrons, and neutrons, we're able to calculate them in these atoms. So in this case, the number of protons is 3 because the lithium is like this. So the number of protons is 3 because the number of protons is equal to the proton number. The number of electrons is to be 3 because the number of electrons are equal to the number of protons. The number of neutrons, we said you subtract the mass number minus the atomic number, which we are going to get 4. Okay. Now this is an atom of lithium. This is an ion of lithium. This one is neutral, but this one is charged. So if you form an ion from an atom, the number of protons and the electrons are no longer equal. So in this case, the protons will still be 3. The electrons will change because here we had 1, we had 2 and 1. In this case, we have lost the 1. So only 2 have remained. The number of neutrons will still be 7 minus 3 is equal to 4. So the difference between an atom and an ion of the same atom is that the number of electrons will be different because the atom, in this case, it has lost 1 electron to form the ion. But the number of protons and the number of neutrons will remain the same. So in the lesson where we studied the atomic structure, we said an atom is a neutral particle. So in the neutral particle, the number of protons and electrons are the same. But an ion is not a neutral particle, it's a charged particle, meaning that the number of protons and electrons are not the same. So the protons and the neutrons, they are not involved in chemical reactions. That's why they are the same. But the electrons are involved in chemical reactions. That's why when forming an ion from an atom, there is a chemical reaction, and in this case, it has lost 1. The 3 will become what? 2. So we're going to look at another example. Let's say in calcium. So calcium, I've got these 2 numbers, the mass number and the atomic number. So we said the atomic number, that's the one that is very important in terms of chemical reactions. So for calcium, atom is 2,8, 2. The calcium is going to lose the valence electrons, which are 2 electrons in the last shell. So after losing 2 electrons, the calcium will become 2 plus 2,8, 8. Now, if we are to draw the structure for calcium, we're going to draw it like this. The 2 electrons, we have got 8 electrons. We have 8 electrons. Then we have got 2 electrons. Okay, and this one, we have got the 2 electrons. We have got the 8 electrons, and we have got 8 electrons. So if we're drawing the structure of an ion, you have to put square brackets, and you put in. So the charge, you can put either +2, or you can put the positive behind the 2 is just okay. But in most books, they'll put the positive in front of the number. So this one, it shows that this calcium had another shell that had 2 electrons. The positive is telling us that that shell, which had 2 electrons, it has lost the 2 electrons, and now only 8 electrons has remained. Now, so if you look at this electronic configuration, which is 2,8, is the same electronic configuration for argon. So argon was 2,8, and argon is a noble gas, so it will look like this. So the calcium, for it to have an electronic configuration like for argon, it had to lose 2 electrons. So all the metals, all the atoms for metals on the periodic table, they have to lose electrons in order to have the configuration like for noble gases. So for lithium, we have seen that lithium, after losing 1, so lithium structure, it's a simple one. After it loses, it only has this. And in this case, it has lost 1. So this electronic configuration, which is like this, 2, so this is just 2, is the same electronic configuration for helium, which is just the 2. So each atom of a metal on the periodic table, it has to lose electrons in order to look like the electronic configuration for noble gases. So all the metals or all the atoms for metals, they will lose electrons so that they've got a stable configuration. If they have a stable configuration, it means they are unreactive. So the losing of electrons is what we say a chemical reaction has taken place. So atoms for metals, they react by losing electrons. When they lose electrons, they're going to have a positive charge. The size of the charge depends on the number of electrons they are going to lose. Okay, so after looking at the losing of electrons, let's look at now the gaining of electrons. Now, gaining of electrons, we have said, is only for atoms for non-metals. So when they gain electrons, they're going to acquire a negative charge. So these ones will have a negative charge. And the size of the charge, it will depend on the number of electrons they will gain. So these electrons they are gaining, they are coming from metals. We said metals, atoms for metals, they lose electrons. Then atoms for non-metals, they gain electrons. So when they gain electrons, they will become negative charge. Then the size of the charge, whether it's positive 1 or whether it's negative 1, negative 2 or negative 3, depends on the number of electrons they are going to gain. Let's look at an example here. So atoms for non-metals like oxygen is 2,6. So oxygen has got 8 electrons, and among 8 electrons, the first shell must have 2, the second shell is going to have 8. So if you're not familiar with the electronic configuration, you have to look at the lesson in which we are looking at the arrangement of electrons in an atom. That's when you're going to understand more on this one. So oxygen has got 6 electrons in the last shell, and we said the valence electrons, they will tell us in which group of the periodic table it is found. So oxygen is found in group 6 because there are 6 electrons in the last shell. Now, these 6 electrons, for oxygen to be stable, to have an electronic configuration like for neon, where neon has got 8 electrons in the outermost shell, it means oxygen must gain 2 more electrons. We want these 6 to become 8, then oxygen is going to be stable. So the oxygen is going to gain 6 electrons. This is going to 2 electrons. So in this case, we're going to have 2,8. After gaining 2, we said because of gaining, we're going to have a negative charge. The size of the charge depends on the number of electrons it has gained. In this case, it has gained 2 more electrons. From 6 to become 8, you add 2. So it has gained 2 electrons. So this is an atom of oxygen. This is an ion of oxygen. In this case, so oxygen has got electrons here, they are 8, but electrons here, they are 10. So the number of electrons will be different as well. So in this atom and in this ion. So these ions, they are negative because non-metals, they gain electrons and going to have a negative charge. But the number of protons and the number of neutrons will remain the same. An atom for non-metals, it must gain electrons in order to become stable, like the electronic configuration for noble gases. So we have seen oxygen, for it to be stable, it has gained 2 more electrons. Now if you look at fluorine, it has 2,7. So in this case, fluorine 2,7, for fluorine to become stable, it must gain 1 more electron so that the 7 become 8. So after gaining, it becomes a negative and it becomes 2,8. So fluorine is stable now. Electrons here, they are 9. Electrons here, okay, they are 10. So fluorine has gained 1 electron to become fluorine ion. Now in this case, this is the oxygen, but this one will be called the oxide. So we're going to remove the last 4 letters from oxygen and you put IDE. So this one is fluorine. You remove the last 3 for this one, it will become fluoride. So if it is chlorine, it will become chloride. So the last part of the name for non-metals changes, but for metals remain the same. So for non-metals, after gaining electrons, it will change. While for metals, it will still remain the same. So all non-metals, they will gain the electrons. Now, how are the structures for these ions? So for oxygen, it has 2, then it has 6. After gaining electrons, now it becomes an ion. So it has 2, then the 6, then it has gained 2 more electrons. So I'll use dots here to show that it has gained 2 more electrons. And I'll put square brackets, and in this case, 2 electrons have been gained. So these 2, they are showing that oxygen has gained 2 electrons. It was like this, but now it's like this. So the electronic configuration, 2,6. This one is 2,8. So even for fluorine, 2 electrons, they need 9 electrons. Then 7 electrons here to make 9. So after gaining 1 more electron, now the electronic configuration is like this. So we have added the 1 electron. This is the negative. So this one, 2,7. This one is 2,8. So this is the oxide, this is the fluoride. Remember I said the name must end with the IDE after losing electrons, after gaining electrons. So the metals, they lose electrons. Non-metals, they gain electrons. When non-metals gain electrons, they acquire a negative charge. The size of the charge depends on the number of electrons they will gain. So if it gains 1 electron, it will be -1, like fluoride here. When it gains 2 electrons, it will be -2 or 2 negative, like for oxygen. So when you write like this or you write like this, it's the same. So for negatives or positives, whether it's like this or it's this, it's the same. We'll still be given a mark when you write like that. Okay. So we can give more examples. The question that they can ask you on this part is, draw the structure of an ion of fluoride, which looks like this, or draw the structure of an ion of oxide, which looks like this, or they can draw the structure of the oxygen, which looks like this. So in this part, you must know how to write or to draw the electronic configuration for both ions, which are positive, and the ions that are negative. So in this lesson, we have looked at losing of electrons by metals and also gaining of electrons by atoms of non-metals. So this topic is very, very important for you to understand so that you can have more knowledge and you understand better when you're looking at bonding. So for today, we're going to end here.